Molar conductivities at infinite dilution at 293 Kelvin for aqueous HCl, HCONa and NaCl are 385, 95 and 115 Simon centimeter square mole inverse respectively. Molar conductivity of HCOOH formic acid at some other dilution is 110 Simon centimeter square mole inverse at 293 Kelvin. Degree of ionization of formic acid is here 110 is lambda m value. By using the lambda m naught values of HCl, HCONa and NaCl, we need to find the lambda m naught value of the formic acid. To calculate lambda m naught value for the formic acid, that is HCOOH, first we need to identify out of these three strong electrolytes which is having two common ions. Here NaCl is having the two common ions. Na is a common ion in HCONa and Cl is a common ion in HCl. The lambda m naught value of NaCl should be subtracted from lambda m naught value of HCl and HCONa to cancel the common ions. When we cancel the common ions, we will get lambda m naught value for formic acid. So the formula will get here lambda m naught of the formic acid HCOOH is equal to lambda m naught of HCONa plus lambda m naught of the HCl minus lambda m naught of the NaCl. Why we are subtracting? To cancel the common ion, that is Na can be cancelled and Cl minus also can be cancelled. Remaining is HCO minus and H plus, that is equal to lambda m naught value of the HCOOH. The value is 95 for HCONa, HCl is 385 minus NaCl is 115, will get the value 365 Simon centimeter square mole inverse. And lambda m value is given for a formic acid, that is 110 Simon centimeter square mole inverse. Now we have lambda m naught value and lambda m value. We can calculate degree of ionization alpha. Alpha is equal to lambda m by lambda m naught. Lambda m is 110, lambda m naught is 365, that is 0.301. So degree of ionization of formic acid is 0.301, option D.